This is the Bogart. Yeah, like Humphrey Bogart. I promise you, the Chinese companies that put these things out, we'll name them anything. But this is the Bogart combination bridge and tailpiece, wraparound bridge and tailpiece off of Amazon. You see, I've already opened it, but I wanted to show you what the packaging looked like and that kind of deal. This is a very cheap. It was $11. A combination. Let me see if I can get this open. I'm gonna be off camera a minute, but it's a combination wraparound tailpiece and bridge. They sell these for the LP juniors and stuff that have the stop bar as a bridge and stuff like that, where there's not a lot of intonation, not a lot of ability to intonate the instrument. And this is a nice bridge for $11. This would be hard to beat. The strings go through here and wrap over the tailpiece and over the saddles. Now the saddles and probably the whole flipping thing is a zinc alloy. And to be honest with you, unless you're spending a lot of money, you can get aluminum bridges and steel bridges and all like that, but most of them will still have a zinc alloy saddles on them, unless you start spending a lot of money on the hardware. And honestly, I do not spend. It comes with the studs, but I do not spend a lot of money for what I am doing. Building is more important than putting $600 or $700 worth of hardware and electronics in every build that I make, or $400 or $200 or whatever you want to spend. I spend as little as I can building guitars, because for me it's about improving the way that I build, and not so much I'm not trying to make, you know, a boutique guitar right now. As far as hardware and electronics and stuff goes, I want to build the very best instrument that I possibly can, and the next time I build, I want to build a better one, and the next one I want to be better and better and better, so on and so forth, as far as how it's built and made. And if the parts are similar to what would come off a budget Squier or a budget Epiphone, they work perfectly fine for me. Okay, because all I'm doing is playing around at home, things like that. Now, if I got to a point where I wanted or needed higher quality hardware and pickups and electronics and stuff like that, it would be easy to pull all of that off and put good stuff on. But like I said, my focus is on being a builder, learning to build it better and better and better. And so I need a bridge that'll intonate. I need a bridge that will work well, so that I can learn to build and be able to judge whether the instrument and what I have built is any good. And so I use what people would consider low quality parts to build guitars. Hello there. I want to do like a kind of a tutorial on how I determine what neck angle I'm going to use on an instrument. And you need, in my opinion, 4 measurements. You need your scale length, the height of your bridge at its lowest point, the height of your saddles at their lowest point, the whole thickness of the bridge from the face of the guitar to the top of the highest saddle, which is usually the center saddle. Okay, and that includes any kind of little mounting studs or anything that will set proud of the body. Okay, then you need the thickness of your fretboard. In this case, that will be 1/4 of an inch. And I like to have the distance from the 16th fret to the bridge location, which in my case is 9 3/4 inches. And so what I do, this is for a guitar that has a fretboard that lays flush to the body like a Les Paul or something like that. This is not for an instrument that has a bit of rise to the heel of the neck like Fender. The Fender neck pockets generally are 5/8 of an inch deep because the neck is 1 inch, and they have, including the fretboard, the thickness of the heel is 1 inch, and they have about a 3/8 inch rise off the body of the fretboard. If you are designing that system and you don't want to raise it up, in other words, it takes more height than that to get your action, so you want to put an angle on it, a neck angle on it, then you have to add in that factor into this equation. But what I'm going to do is, I know that my fret, or my scale length rather, is 24, and it's 24.562 or 24 9/16. So I'm going to mark right here, that's the position of the nut, and I'm going to come down here 24 9/16. And I'm going to strike me a line. That is the distance of the scale. That is the scale length of this instrument, from nut to the top of the saddle bridge position. And I know that my 16th fret will join up 9 3/4 from this bridge location. You could just measure from here to where the 16th fret is. That would work too. From the nut to the 16th fret is 14 13/16. So I could do it like that as well. I could go 13/16. And if I measure that, it's 9 3/4. Right dead on the money. Okay, so this is the 16th fret. That is, and so what I want to do is I have a 1/4 inch thick fretboard, right? So we're going to do that. We're going to go from here. We're going to 1/4 inch there. And go down here. You'll have to excuse my head if that's what you're seeing, because I didn't make myself pretty for you this morning. So we're going to join that. Right? Now people will say all the time, well, what's that angle? It don't flipping matter what that angle is. You don't have to know that angle. I don't care one tiny little bit what this angle is, because depending on what I use, okay, it'll be different pretty much with any kind of bridge that I use. And so I don't care what this angle is. So now, right, we've got the neck and the body laid out on a flat, on the same plane, like the neck and the body will be joined together. Okay, and I have a 1/4 inch rise. This represents my fretboard, correct? what I'm going to do now is I'm going to put a 1/16 of an inch there. And at the nut. The reason for that is this is, I'm going to say that's fret height. It's a guess. Your frets are going to be higher or lower. Just for grins and giggles, that's my fret height. Alright. So, at the bridge location, the bridge height is 13/16. Remember? So, we're going to go there's 13/16, right? So now if I do this, if I lay a straight edge here and here, top of the fret, top of the bridge. Alright, now you see that action is untenable. Can't do anything with that. There's no way to correct that without a neck angle. So I'm going to put me a little straight mark there just because I want to. And I'm going to go and measure from there to here. And that is 5/16, just a little under. If I really wanted to get technical with it, I'd have to go get some magnification. But if I really wanted to get technical with it, I could take my 32nd inch rule and say that that's 9/32. A 32nd of an inch ain't gonna matter at all. I'm going to call that, let's see, 5/16. So what I need at the heel of the neck, of the body, is a 5/16 drop. And that would bring the fretboard up in line with this. That's it. That's all I need to know. I'm going to mark 9/32 inch plus or minus, so 5/16. And I just happen to have a piece of ebony here that is actually 5/16 of an inch thick, and I'll just set that underneath the heel, and Bob's your uncle. I'll route to that. But that's how I do it. Do I know what that angle is? No. Do I care what that angle is? No. Doesn't make a dime's worth of difference. I just know that'll work. And I can repeat this process with any guitar that I'm making. I don't have to know any math or anything like that. And now you can, what I will do is I will come like an inch from where the saddles are from this scale position. I'll come back an inch. Okay, and that'll give me clearance for the foot of the bridge and stuff like that. I'll put this block up underneath here, and I'll set my router. I'll put this in the body in a router sled. I'll set this 5/16 piece of wood underneath the heel. Make sure everything is nice and solid. What that'll do is elevate the section where the neck joins the body. Okay, and I will take and come back 1 inch from here. That gives me room for the plate, the bottom plate, or whatever that's going to be on the bridge. And I'll set this in that router sled. I'll set my router on it and adjust a bit so it's right at the top, touching the top of this body at the 1-inch mark. And I'll just take the router plane and route all the way down, and because this is lifted up on this end, it will route this angle into the top of my instrument. That's how I calculate the neck angle that I need to use, and it comes down to the thickness of a piece of wood that I'm going to use underneath the heel of this body to get what I want.